we're going to look at 3 problems as kind of extra practice and extra help for anyone who needs some with this particular topic of rational functions. The first one we're going to look at is I didn't have an f of x in here. It's f of x equals 2x squared minus 18, and it's over 5x cubed minus 15x squared. So one of the first things we can look at is the end behavior asymptote. And remember that we do that with our leading terms before we factor. And if we simplify that, we can see that it's going to be 2 over 5x. And that's going to behave simply like our proper rational functions, like a 1 over x. And if we get back to one of our proper functions, the end behavior asymptote is just y equals 0. The next thing we're going to have to do is some factoring. And once we factor, we'll be able to determine what all of the other pieces are, like vertical asymptotes and holes and things like that. So I'm going to take out the GCF first, and that is always a good step. And I'm going to notice that I have a difference of 2 squares in the numerator. Oops, I don't know why I put 2. 3 and 5x squared, and then x minus 3. And then I'll put the simplified version here, and the simplified version is going to have our x minus 3's cancel, and we have 2x plus 3 over 5x squared. So that right there is our simplified version, and we're going to use that for a lot of our things. All right, let's look at, let's see, how about the vertical asymptotes? So we're going to abbreviate it VA. So the vertical asymptotes come from any uncanceled factor of x in the denominator. So if we look in the denominator, we have an unfactored or an uncanceled piece of x, and we can actually factor that into x and x. So that means x would be 0, x would be 0. So how many times do we see x equals 0? Twice. So our vertical asymptote is x equals 0, and it's going to have a multiplicity of 2. And having that multiplicity of 2 for the vertical asymptote means that our ends are going to go in the same direction on either side of that asymptote. Let's see, let's look at maybe the hole. Is there a hole? Well, the hole is going to be whatever factor that we canceled. So x minus 3 equals 0. So my hole is going to occur at x equals 3. And in order to figure out the exact location of that hole, we need to do a little work. So we're going to plug in 3 to our simplified expression. So we'll have 2 times 6 over 5 times 9. And let's see, it's going to be 1245. And then each of those can get reduced more. And we have 4/15. Okay, so the hole is located at 3 4/15. All right, let's see what else we have. We can do the x-intercepts. So the x-intercepts, those are going to come from any of the uncanceled factors in the numerator. So my x-intercept is going to be at -3. And then we have the y-intercept, and the y-intercept is always found by plugging in 0. And you can plug it into the original, or you can plug it into the simplified. So I will do that. We are going to have 2 times 0 plus 3. Oh, sorry. Yeah, 0 plus 3 is 3. And then 5 times 0. And we can't have a 0 in the denominator. So we do not have a y-intercept. And if you can think about why we don't have a y-intercept, that's awesome. And maybe I'll talk about that sometime in class, but see if you can figure out why in this graph we have no y-intercept.